work out an example for this particular situation here. So the problem is a study was performed on 200 elementary school students to investigate whether a regular vitamin A supplementation was effective in preventing colds during the month of March. 100 were randomized to receive daily vitamin A supplements during the month of March, and 100 students were randomized to a placebo group and did not receive vitamin A. During the same month, the number of students getting at least one cold in March was computed in the two groups, and the results are given in the following 2x2 table. So here you have the medication. So medication, in this you have vitamin A and placebo. And here you have cold and no cold. No cold. So the numbers are given. So this is 15 and this no cold is 85. Here it is 25 and the no cold is 75. Right? And then of course you have the total there. So now the question is, test whether the medication has any relationship in terms of the cureness of cold or no cold. Okay, so you're asked to test the hypothesis. It's given here, testing the null hypothesis. The question is a research question. There is no relationship between the medication taken and the effectiveness and the cure for cold. Okay. So that means the children, those who taken the medication, has vitamin A and placebo has any effect on curing their coldness, right? So cold or no cold. Okay. So now we are going to study the relationship between these two factors here. So the medication taken is one factor, and the cure, whether they are cured or not, okay, from the cold, that is the another variable. Okay. And this is the test you need to do it, and at 5% significance level. Okay, at 5% significant level. So now I'm going to solve this problem here, and then you can easily understand. Right? It's very simple exercise. So vitamin A, placebo. Okay, and then you have cold, no cold, and then here you have the total, and here also you have the total. So vitamin A is 15 cold, 15, and this is 85, and this is 25, and this is 75, and this total here is 100. This is 100 here. Similarly, here is 40, and this is 160, and the overall total is 200, the grand total. Okay. So now I want to calculate. So these are all the observed frequencies, right? These are observed frequencies. So now we need to calculate the expected frequency for each cell. So expected frequency of 15 equal to, so 15, so you need to take the corresponding total, column total is 40 times the corresponding row total, which is 100, divided by the grand total, which is 200 here. Okay, so this is equals to 20. and the expected frequency of the next cell, which is 85. So that is equals to, you have to take the corresponding column total, which is 160, times the corresponding row total, which is 100, divided by the grand total, which is 200. So this is equals to 80. Similarly for this one, so expected frequency of 25 equal to the expected frequency of 25 equal to 40 times, and the corresponding total is 100 over 200, so which will give you 20. The expected frequency of 75 equal to 160 times 100 divided by 200, which is equals to 80. Right? So these are all my expected frequencies. So now I have to calculate the test statistic divided by E. I'm going to do it in one step. So O, these are the observed frequencies. I write it one by one. 15, 85, 25, 75. And the corresponding expected frequencies 20, 80, 20, 80. Okay. And my O minus E the whole square divided by E is this is 1.25. So that means 15 minus 20 the whole square divided by 20. Okay, that's 1.25. So for this one is 0.3125. This 1.25 again and 0.3125. Okay, and we need to get the total of this, which is 3.125. Okay, so my chi-square calculated value equal to 3.125. Right? So step 1, you need to state the H0 hypothesis. That is, there is no association between medication taken and cure for cold. Okay, cure for cold. And H1, we say that there is an association between medication taken and cure for cold. Okay, so step 2 is the critical region. So as I said, the graph goes like this, and you have 5% significant level, so chi-square 0.05, comma, and the degrees of freedom equal to R minus 1 times C minus 1. The number of rows minus 1 times number of columns minus 1. So here you have 2 rows, so 2 minus 1 is 1 times number of columns 2, so 2 minus 1 is 1. So 1 times 1, you will get 1. So it's a 1 degree of freedom. So that value is equals to, so the degrees of freedom is the number of rows minus 1 times the number of columns minus 1. Okay, so here we have 2 rows minus 1 times the number of columns is 2 minus 1. So this 1 times 1, you will get 1. So the degrees of freedom for this is 1. Okay, and now we have to read that value from the chi-square table here. So the degrees of freedom is 1 and the alpha is 0.05. So chi-square is 0.05 and 1. So you will get at intersect at 3.841. Okay, so that's the value I'm getting, 3.841. So chi-square equal to sum I is equals to 1 to n OI minus EI the whole square divided by EI. So that we already calculated, so that is 3.125. Okay, and then step 4, you need to make a decision here. So since chi-square calculated value, which is equals to 3.125, is less than chi-square tab, which is equals to 3.841. Okay, we reject. We accept H naught. Okay, so what does it mean? Then whether you've taken a medication of vitamin A or placebo, right? But there is no relationship between somebody to get cure from cold. Okay, so there is a saying that for cold, whether you take the medication or not, but still it will be there for a week.